Hello, I'm Ronnie Grand. Welcome to the Landsat Data Continuity Mission Science Briefing. We are coming to you from Vandenberg Air Force Base. Today you're going to hear about how this new satellite is going to help us understand our changing planet and also manage our food and water resources better. After our presentations from our four speakers, we're going to take questions here in the audience, but also on Twitter at #AskNASA. Now I'd like to turn this presentation over to Jim Irons.
Thank you, Ronnie. I'm Jim Irons. I'm the project scientist for the Landsat Data Continuity Mission, and I'm thrilled to be here at Vandenberg Air Force Base for the launch of the mission, which we also call LDCM. Monday's launch will be the culmination of years of hard effort by a skilled workforce at NASA, the U.S. Geological Survey and the Department of Interior, Orbital Sciences Corporation, Ball Aerospace and Technologies Corporation, the United Launch Alliance, Hammers Corporation, Vandenberg Air Force Base, and all of our other industry partners. I want to express my deepest appreciation to these organizations, and in particular to their employees, for the dedication and devotion that they have shown to the success of this mission. And while, for me, the launch on Monday will be heart-stopping, as it will be for all of us who have been involved in this effort from cradle to ignition, the real adventure will begin when people like my distinguished colleagues on this panel have an opportunity to get their hands on the data from LDCM and begin to advance their scientific investigations and improve their resource management applications with the best data yet from a Landsat satellite. Now, we have operated Landsat satellites for over 40 years, beginning with the launch of Landsat 1 in 1972. During that time, there has always been at least one Landsat satellite in operation observing the global land surface, and we have never suffered a gap in the continuity of these observations. The launch of the LDCM is particularly timely. We recently decommissioned Landsat 5 after a remarkable 28 years in service, and the only Landsat satellite that remains in operation is Landsat 7, which was launched from right here at Vandenberg Air Force Base 14 years ago. Meanwhile, our forests are being disturbed. Irrigation is placing increasing demands on our scarce water resources. Cities are expanding to accommodate growing populations. Ecosystems are changing, and glaciers are retreating in advance of climate change. And all of these changes are currently occurring at rates unprecedented in human history due to an increasing population, advancing technologies, and climate change. We will be able to monitor these changes, to continue to observe these changes from LDCM, from the best Landsat satellite ever launched. Why do I make that claim? I call LDCM the best Landsat satellite ever launched because we have incorporated technological advancements into the two instruments on the satellite's payload. The Operational Land Imager, or OLI, built by Ball Aerospace and Technologies Corporation in Boulder, Colorado, and by the Thermal Infrared Sensor, or TIRS, built by NASA Goddard Space Flight Center on site at Greenbelt, Maryland. These technical advancements that I referred to will increase the ability to describe the landscape, improve the ability to describe the landscape with LDCM data, and will render the data more sensitive to land cover change over time. It's not called, however, the Data Continuity Mission for no reason. The data from the LDCM will be compatible with and comparable to the data collected by all the earlier Landsat satellites. And the data will, the U.S. Geological Survey's archive of this data, to which LDCM will add data, will allow us to reach back 40 years into that archive to study 40 years of change, to understand where we've been, and to better predict where we're going. I will now turn this press briefing over to the rest of the panel in order to discuss in more detail how we will put this wonderful new observatory to work. Next is my good colleague from our partner agency, the U.S. Geological Survey, Dr. Tom Loveland.
Thank you, Jim. I want to tell you how happy I am to be here today, and on behalf of the many, many Landsat users around the world, I would also like to express my appreciation to the many people, both within industry and governments, that contributed to the development of LDCM. With the launch of the Landsat Data Continuity Mission, which the USGS will rename Landsat 8 sometime this spring, we expect to have more data, better data, and new measurements that will lead to new science and applications with worldwide benefits. Perhaps more important than anything else, though, is that the Landsat Data Continuity Mission really lives up to its name. With the addition of the imagery from this mission to the current Landsat archive in Sioux Falls, South Dakota, within the USGS, our record will move from 40 years to 45 to 50 years, or hopefully beyond. And that should allow us to have far better information to understand the causes and consequences of environmental change. Since 1972, the U.S. Landsat archive in Sioux Falls, South Dakota has accumulated close to 3.5 million images. Those images are available to anybody in the world at no cost. And in fact, the importance of this is illustrated by the fact that we distribute now over 3 million images per year to users in over 180 countries. So we really truly have a worldwide resource through the Landsat program. The LDCM data quality improvements and data quantity increases are going to be very valuable as we try to study the changing Earth. LDCM offers significant benefits to all users, whether it's scientists trying to understand the underpinnings of climate change, or resource managers trying to develop strategies for sustaining the natural resources of the planet. All require continuing flow of imagery, and LDCM will meet that need. The new capabilities with LDCM that were mentioned by Dr. Irons are expected to be especially important in a couple of areas, one being agricultural monitoring and the other water resources management. Let me talk briefly about water. Water is essential for survival, quite obviously. About 70% of our planet is covered with water, yet only a small fraction of that is actually available for human consumption. Ensuring the wise use of that scarce resource and maintaining the quality of our waters within our water supply is a critical societal goal. Some of the new capabilities on the operational land imager are showing us through some of the early research that we are going to have the opportunity to use Landsat imagery to better understand water quality in the United States and around the world. That's a major advance in applications. The Landsat Data Continuity Mission's second instrument, the Thermal Infrared Sensor, or TIRS, is also going to have a significant contribution to water resources management. It will allow more precise and more accurate measurements of water use on a field-by-field basis. This is particularly important to western states in the U.S. that are trying to manage a water source that is in demand for agriculture, for industry, and for residential use. And so our ability to improve our estimation of water use should improve all sectors. We also expect to see significant advances in agricultural applications domestically and internationally. When we look at the United States, for example, the agricultural production in this country is in excess of $200 billion per year. And so our federal programs that map the types and the extent of crops needed to understand what the food supply will be and the impacts on the market will benefit greatly from this. And as well, our crop insurance programs that need timely information on the condition of crops will also make strong, effective use of LDCM. Internationally, it's even a bigger deal. With the increased quantity of data that are going to be available, our ability to monitor in a more timely fashion agricultural production around the world is going to be much improved. And that's a big deal. When we think about the fact that we have 7 billion people on this planet, we're increasing that population by about 75 million people a year. Meeting the food security needs of the planet is obviously a critical issue, one that LDCM will benefit. About 40.5 years ago, here at Vandenberg Air Force Base, the first Landsat was put into orbit. And since then, 6 other Landsats we've had, and since then we've had 6 Landsats that have effectively created this unprecedented record of the condition of the Earth's surface. That record has had a huge impact in modernizing natural resources management and improving our scientific understanding of environmental change. We know that LDCM, or Landsat 8, in just a few months, will continue this record in, an unprecedented fashion. With that, I'd like to turn it over to my colleague Cass Green that's going to talk about the extensive use of Landsat in both public and private sector. Cass?
Thanks, Tom. Well, first I want to offer my heartfelt thanks to NASA, the Air Force, Department of Interior, USGS, and all the contractors and public servants who have made this launch possible. This is an incredible event, and the launch of LDCM will continue the record of Landsat Earth observations, a record, as my colleagues have mentioned, is over 40 years long, starting in 1972. It's an incredible data set. It's a data set that U.S. government agencies use to ensure our country's environmental security, food security, and homeland security. In terms of our environmental security, NOAA has a coastal change analysis program that monitors change in coastlands over time. The Forest Service uses Landsat data to monitor forest health. The state of California consistently monitors land cover change throughout the state, and Idaho and other western states monitor water use using Landsat data. So the resource is incredibly important to state, local, and federal agencies. For food security, the Department of Agriculture has several programs. One uses Landsat data to monitor food production in the United States so that we all know what amount of food is being produced here. Another looks at food production globally so that farmers in the United States can know where they sit within the global agricultural market. On the other side of agriculture, you've got USAID, FuseNet, who uses Landsat data as part of their package of resources to monitor famine worldwide, trying to ensure that we can stop hunger throughout the world. In terms of homeland security, FEMA has a flood mitigation program and USGS has the land fire program. Both of these programs measure risk, use Landsat data to measure risk and help our country as a whole to avoid those risks and to respond to natural disasters when they occur. So the country has a major requirement for Landsat data, and even though most of those requirements are from government agencies, the free and open data policy of Landsat data has invigorated a whole investment in the commercial sector. And that's been really, really interesting to watch. There's all kinds of innovation. There are all kinds of things that nobody ever thought about that have occurred only with the free and open data policy. I'm going to give you some examples and show you some examples. One that's familiar to probably all of us is Google Earth. Whenever you're on Google Earth, you go into a regional level where you're looking at a state. You know what you're looking at? You're looking at Landsat data. Another example is MDA Information Systems. They have a product that they sell to their clients that monitors annual change and goes back for a 40-year period. The next one, which I want to show on a slide here, on the image here, is AER's product, which is called Fireline. And Fireline is used by the insurance industry throughout the western United States to monitor and manage their portfolio risk to wildfires. And then finally, I want to talk about ESRI's Change Matters, which is a website that allows anyone in the world to look at change anywhere in the world. So it's a free website. You can go on site and you can look at change from the 1970s all the way up to 2010. And then when the new satellites come up, we'll be able to continue to update that over time. The first image is of the Outlook fire, which occurred in 2006. In the north rim of the Grand Canyon. It was an explosive fire, and you can see on the image 1990 before the fire, and then we've got 2000, must have been 1996 was the fire. Then we've got the 2000, and you can see to the far right an image which is a comparison of the before fire and after fire image, and it shows the extent of the fire. And that helps the Park Service go back and regenerate that area following the fire. The next image is of redwood regeneration in Northern California. Here we're looking at an area near Corbell, California. It's part of the redwood region. And in 1990, most of that area has been cut over. It's a clear-cut redwood forest. But now we get to 2010, and that redwood forest is completely regenerated and is full of young, healthy trees. So you can see just the change in forest over time. Then we can look at the conversion of farmlands to suburbs outside the Washington, D.C. area. Again, we're looking at 1990 to 2005. You can see the expansion of Dulles Airport on this imagery. You can see in the 1990 imagery of a pattern of small farms, and you get to the 2005 imagery, and it's completely suburbs. So you can monitor land use cover over time. Next image is of lake level fall. As most of us know, the Colorado Rockies have been experiencing a drought over the last 15 years. That's caused a huge impact to Lake Mead, and Lake Mead has dropped over time. So in these images, you see in 1975, Lake Mead at fairly full. Then we go to 2010, it's dropped significantly. And the image on the far right with the green bathtub ring, we call that the bathtub ring around Lake Mead, is showing the drop in Lake Mead over that time period. And then my last image is of Mendenhall Glacier in Alaska, and you can see the glacier retreat, again, over a 20-year period, only 20 years. This is an infrared image, which is a different way of looking at the different bands on Landsat, and you can see the significant retreat of the glacier over this 20-year period. So this imagery has been, I'm in the private sector. This imagery has been amazingly important to my career. It was the foundation of my first company. It is critically important to my second company. Now I'll get teary-eyed, I hope not. And even more important, it's important to the citizens of the United States. And I think now what we must all do is look forward. And we must ensure that there is another Landsat and many more Landsats to come. There must be a Landsat 9 and a Landsat 10. We need to make sure that there's a Landsat program that will ensure that future generations can look back and see where we've been so they can plan where we're going. Now, I've spent most of my time talking about the domestic needs for Landsat data, and I'm going to turn over to my colleague, Mike Werler, who's going to talk more about the international needs for Landsat.
Thanks, Cass. As Cass mentions, I'm Mike Wolder. I'm with the Canadian Forest Service of Natural Resources Canada, and I've been asked to speak to international and science perspectives on the Landsat program. And before doing that, I'd really like to thank the organizers for that invitation. I'm really quite honored, and really honored as well to be representing the vast community of global Landsat users, both in the monitoring and science communities. So, of the environmental issues that face humanity today, climate change, pressures upon biodiversity, sustainable use and stewardship of natural resources, just to mention a few, Landsat data plays a critical role in enabling scientific inquiry. How so? Well, Landsat data is a global resource, empowering nations to individually monitor and report. Further, Landsat data allows us to see what the world looks like and how it has changed over time. And if you could roll the video that shows Las Vegas, we can see a change example. And what you see there as well is that Landsat imagery portrays the world to us at human scales. And another thing to recall is that Landsat images are not just pictures. Each pixel relates scientifically calibrated, wavelength-specific physical values. Innovative image processing opportunities facilitated by the USGS free and open access to Landsat imagery are really resulting in a number of novel processes that we can apply for understanding the information that's available in these images. With that availability of the imagery, I'd really foresee over the next decade the capacity of our community to reconstruct the history of the globe using this Landsat data. So you can really consider right now as being a watershed in the use of Landsat data. The free and open access to the imagery has fostered several key innovations that have allowed the science and applications communities to increase their impacts in terms of space, time, and the information that can be generated. So over space, our capacity has increased through a novel pixel-centric view. And I can see we've started the video here showing web-enabled Landsat data. And what you can see here is where multiple overlapping images are used to create image composites that then can be used for our applications and scientific work. Over time, the systematic collection and archiving of imagery since the inception of the Landsat program has enabled sophisticated time series analysis to be undertaken. Not only can we see catastrophic or discrete events like wildfire or urban expansion, we can also see gradual changes that would be related more to vegetation stress or changes in water levels. Further, regarding the information generated, the production of land cover maps is increasingly automated, with additional richness incorporated through modeling and the inclusion of other complementary data sets. The physical nature of the Landsat measures also allows us to model important climate variables, such as surface temperature and reflectance, as well as the estimation of biophysical attributes such as biomass. So combining all these aspects through intelligent data processing and modeling will provide us with unique information that is not readily available from any other data source. A spatially comprehensive, temporally deep, and categorically rich recreation of the history of the globe since the inception of the Landsat program is now within sight. It will certainly keep many of us busy. The USGS Aero statistics show a very high number of academic downloads, indicating that many new investigators are learning with and about Landsat imagery, and will certainly be poised to help with tackling this ambitious vision. So if you could roll the next video, it really shows the global reach of the measures that we do, from the polar ice caps all the way through to uninhabited forest environments. And it's with this information that national and international bodies are increasingly implementing national mapping programs. The use of the same data allows the outcomes between these endeavors to be readily compared, and a dialogue regarding the statistics generated can be undertaken. Recently, the United Nations Food and Agricultural Organization implemented a remote sensing survey based upon samples of Landsat imagery to produce global statistics for both regional and global statistics on forest resources. At the national level, many nations have long-standing programs, and actually quite successful programs, from forest monitoring that are based upon Landsat imagery. As a large and sparsely inhabited nation, Canada uses Landsat imagery for creating maps and in support of a wide range of scientific inquiries. For instance, the most detailed map of land cover ever produced in Canada utilized Landsat imagery. So in conclusion, in Canada, as with many other nations, Landsat is considered integral to our national programs and continues to allow for reporting, applications, policy development, and of course scientific discovery. The continuity and improvement of Landsat measures resulting from the LDCM is anticipated to enhance the range and quality across all of these activities. So thank you for that, and back to you, Jim.
Thank you. You know, Tom, Cass, and Mike, you're three representatives of a crowd I expect to ultimately number in the millions. A crowd that will directly and freely access LDCM images from the Landsat Data Archive maintained and operated by the U.S. Geological Survey. And I expect that you, along with the rest of this crowd, will use those images to conduct the analyses that we need to understand the causes and the impacts of global landscape change. These changes have profound consequences for our global society. They impact our food and fiber production, They impact human health and welfare, impact the availability and quality of our water resources. They impact our global economies and the sustainability of our resources. We need this information that will come from the LDCM data and its analyses to make informed daily decisions about how we conduct ourselves, to use our resources wisely, and to plan and adapt to inevitable change. Our world population now exceeds 7 billion people, and I expect that all 7 billion of us and on into future generations will directly benefit from the results of the Landsat Data Continuity Mission. I further expect that those benefits will continue through the operational life of the satellite as it's operated by the U.S. Geological Survey under its new name, Landsat 8. Thank you. I can't wait to get started. And back to you, Ronnie.
Thank you, Jim. We will now take questions here in the room and also through Twitter. If you have a question through Twitter, just go through hashtag AskNASA. Start with questions in the room.
Hi, Nora Wallace, Santa Barbara News Press. So I'll repeat my question from the previous panel about a lot of you spoke about the interest in this data from the kind of the government and commercial aspect, business aspect. But tell us a little bit about the fascination that you see in just the general public, like schools or, it's a little bit of a time suck when I go on the website and start looking at data, suddenly an hour's gone by. So do you see that a lot in the general public, or what kind of interest do you see in this information?
Just starting to. I mean, not just starting to, but it's really starting to explode once the data became free and open. That's been the huge difference. So people are just starting to really mine that data. But I have a neighbor who's a school teacher. She teaches 7th and 8th graders, and she uses Landsat data in her courses all the time. She's a science teacher, to just show the kids how, the population's changing, our resources are really stressed. So I think, especially with this launch, it's going to really explode. But you see it from the users, from the chart of the users taking off. And God, the imagery is just so beautiful. I get sucked into it too. I just I can't believe how beautiful it is.
I'm glad you brought up education because we make a concerted effort to conduct educational outreach in order to facilitate the use of this information to aid in education. I think that, and since I go back a few years on this program, I think when the Landsat satellites were first launched, there was a fascination in the public with the revelation of the beauty of the landscape and its landforms, its geomorphology. I think that fascination has transferred a bit in more recent years to understanding the impact of our human population on that landscape. So as we've built up a record of observations and we begin to reveal the changes, the dramatic changes that are occurring on that landscape, I think the fascination now is more with what we're doing on it rather than just the natural and inherent beauty of those landscapes.
I think we have another question in the audience here.
Janine Scully, Santa Maria Times and Lompoc Record. We try to, as regular reporters for mainstream media, we try to bring this down to why should the farmer, a vegetable farmer in Santa Maria, the forest ranger up in the Los Padres National Forest, why should they be excited about this, and how will this satellite help them?
There's a number of reasons, but one of the goals we all have is to improve the sustainability of our resources, whether it's agricultural land, forests, or rangelands. The other is to to try to make the wisest possible uses that benefit future generations. You know, the challenge we face in resource management, whether it's agriculture or forestry, is that those are the kinds of activities that tend to operate on smaller budgets than many. And so what we really need is to achieve some efficiencies in looking at the condition of our resources, checking the effectiveness of management programs, and fine-tuning those as we move into the future. With free access to Landsat data, what we're seeing is a huge increase in forestry, a growing interest in agriculture, and much greater uses in range management, all because we finally have a timely resource that's readily available with a long-term commitment behind it that allows resource managers to make the investments in time and staff, and therefore come up with the decisions they need to better use their lands.
I'd follow up just specific responses for the Los Padres National Forest. I can tell you the foresters there are already using products that use Landsat data to monitor forest health. So the Forest Service in this region uses Landsat data to map the national forest and to monitor forest health. So the forester's very interested in it. And the farmer's very interested in the price of their agricultural products. And that price is largely determined by the global price. So you have U.S. Department of Agriculture monitoring global production worldwide. Those numbers go into what's called lockup every month, and then they're released to the press and to the public. So that you put every farmer on a level playing field because that information is out there and they know what's determining prices. So both that farmer and that forester are directly impacted by Landsat data today.
Yeah, if I could add a little bit about some forest perspectives on it. You'll probably have to stop me at some point here. I'll just keep going. But there's a wide range of users that can actually utilize the imagery, right from just putting the imagery in your computer as a backdrop to see the context of their woodshed, all the way through to people that are putting together the 40-year stack of imagery to look at very subtle changes over time that have been occurring. So say a slowly encroaching insect that might be coming into a particular part of the landscape, beetles that might come in or other defoliators, they can see where that is and they can see how that might relate to their actual planned operations. So there's a wide range of different users, so it's really hard just to say this is the one thing that gets done, because the imagery is really allowing them to tackle different problems with a number of different approaches. So even aerial sketch mappers before used to just have a map on their lap and then they'd draw where they thought the infestation was. Now they can have a Landsat image in a digital environment in the background, and they can use all the contextual clues that are there in the imagery to better depict where the insect infestation is occurring. So that's just one example of how it's getting used in a management context.
I believe we have some questions on Twitter.
Yep, quite a few, actually. The first one, when will a first light image from LDCM be released?
Yeah, we expect to open the shutters to view the Earth with OLI and TIRS sometime around the 25th day in orbit. And we'll release a JPEG image of the first light image when that event occurs.
And a related image is, when will LDCM data become available regularly to the world?
Yeah, go ahead.
Yeah, we are expecting to begin providing operational imagery about 100 days from launch, so that would put us in toward the end of May.
Okay, thank you. Next question is, how much longer do you expect the remaining Landsat satellite, Landsat 7, to continue operating?
Yeah, analyses have indicated that there's enough fuel aboard Landsat 7 to keep it in its operational orbit through 2016.
Yeah, let me just add on that point too. With the end of the Landsat 5 mission, discontinuing the acquisitions of imagery about a year ago, we've been in a rare period in the Landsat history where we're only getting 16-day coverage. We don't have those two images that give us the 8-day coverage. Now that we'll be back with LDCM through the end of Landsat 7, we're returning to that 8-day coverage, which really has significant benefits when we're trying to monitor the condition of our landscape.
Okay, and what is the expected mission life of LDCM?
The design life of the spacecraft and the operational land imager is 5 years. The design life of the thermal infrared sensor, or TIRS, is 3 years. There's enough fuel on board the spacecraft to maintain its orbit for at least 10 years. And so we hope that the spacecraft and the instruments will last well beyond their design lives, and we can continue to collect data for at least 10 years.
Okay, the next question is there a technology that you'd like to get on a future Landsat mission that you were not able to get on LDCM?
Oh, man.
Sounds like a yes or no.
How do we want
Yes,
to?
you guys go.
Yeah, I think it's universally yes.
We want
but
everything.
but at the same time, you know, what we do need to always recognize is the importance of Landsat is building this long-term record of the condition of the Earth. And so we put at the top of our wish list data continuity, the ability to continue the same types of observations that are backward compatible to the first images acquired in 1972 is critical. What we need after that is incremental advances in capabilities that'll help us understand the complexity of the landscape, the structure of the landscape, and that leads to a lot of other imaging opportunities. But continuity always drives Landsat.
Do you want to mention increased frequency?
Okay, another question. With readily available high-resolution imagery of Earth available through Google Earth, how do you convince the public of the usefulness of Landsat data?
Well, that data that you find on Google Earth are Landsat data. So the reason Google Earth is able to display that data is because we've operated the Landsat satellites for so long. What Google Earth does not yet do, and may do in the future, is they don't update that as often as we require for our scientific applications and for our resource management applications. So, yeah, I mean, we are, Google Earth has taken full advantage of the Landsat program in order to create their service.
And we understand they're coming to the launch. But the high-resolution data does not have the temporal resolution of Landsat data. By that I mean with the launch of Landsat 8, we'll have pictures of the Earth every 8 days. You cannot do that with high-resolution data because the footprint is so much smaller. So you see more detail, but it takes a very, very small picture of the Earth. And none of the commercial satellites or airborne can we get the kind of temporal resolution that we get with Landsat data. And that's critically important, to be able to take that big picture often enough to manage resources and monitor resources over time.
Okay, the next question is, what is the expected partnership between LDCM and the European Sentinel-2 mission to improve intra-annual observations? And perhaps you could tell the viewers what that Sentinel-2 mission is.
Well, you want me to? Okay.
Oh, you go ahead, Jim.
Sure. The Sentinel-2 mission is a mission of the European Space Agency. They plan to ultimately launch 2 satellites, with the first one going up in the summer of 2014. That will take, and these satellites have an instrument called the Multispectral Imager, MSI, that will collect data comparable to the operational land imager, but not exactly like it. The Sentinel spacecraft will not carry a thermal imager, however. They will not collect thermal data. We have initiated discussions with the European Space Agency for cooperation. We just this past fall conducted an exercise with their vendor for the MSI to facilitate cross-calibration between OLI and MSI. We actually sent some instruments over to their facility in Toulouse, France, to make measurements of their calibration reference sources. And so we are hoping and looking forward to increased cooperation and learning how to use the data from both systems synergistically together.
Yeah, just to follow on that, it comes down to temporal resolution, as Cass mentioned as well, that the more opportunities you could look at a particular place on the land base, the better you can understand it. And there's also the complication that we get in remote sensing because of clouds. So if we have an opportunity to see a location more times, we have an opportunity to clear the clouds, find clear pixels that we can use for our applications, and then for things like agriculture, where they need to know quite rapidly what's changing on the landscape, how the crops are developing, they can see that with those multiple looks. So that's one of the key things that we'll get from a synergy with Landsat and Sentinel measures.
Okay, and now I've got one more question. This seems a bit more technical, so it might need some help from you all. How do the alterations to LDCM bandwidths and band locations affect the data continuity across missions, if it has any effect at all?
Yeah, we've made some revisions to the bandwidths of the sensed by the operational land imager in order to avoid atmospheric absorption features, so that our observations from the LDCM we expect to be less sensitive to atmospheric conditions. They're close enough, though, that we hope that the changes will not impact our ability to compare LDCM data with data from the earlier satellites.
Okay. Are there any more questions in the room?
Roger Eckert, the Arcata Eye. I have a question. You've talked about the increase in use of images since they've become free. Whose idea was that, and how hard a sell was that?
The decision to move to free data was made within the U.S. Geological Survey in around 2007 or 8, and it was a recommendation by one of our senior administrators that realized that the value of Landsat would be greatly enhanced if it were in more hands. So we began the process of designing the systems. Part of the process of that is to make data free. We needed to reduce costs significantly. The primary way of doing that is to make it available through internet distribution. And so we essentially modernized our systems as rapidly as possible, and in late 2008 made that happen. And the first year we distributed over 1 million images. That compares to our best sales year of about 20,000 images, and now we're at the point where 3 million images per year are being used. The investment is building the systems, putting satellites into orbit, and operating those systems through the operational phase. The return on the investment is the effective use of that in all sectors, and that's where we are with free data.
Any more questions in the room? All right. It's going to close our briefing. I want to thank our panelists and thank the people asking questions online and here in the room. If you'd like to learn more about Landsat Data Continuity Mission, you can go to the website at www.nasa.gov/Landsat. Thank you.